يعطيكم العافية شباب وصبايا. اليوم we're going to solve some of the past paper questions that are related to thermal physics. Okay, let's start with this one just to give you a little heads up. This here is the reference for the question in the past paper. So this is October-November paper 3 and 2003. So here we have equal volumes of nitrogen, water, and copper. All of these are at 20 Celsius. So we heated these three substances to 50 Celsius. Which one of the three will have a much greater expansion than the other two? And of course it's nitrogen, because nitrogen is a gas, water is a liquid, and copper is a solid. So the one with the most expansion is nitrogen. Now, explain your answer in terms of the way the molecules are arranged in the three substances. So how can we explain why nitrogen is the one with the greater expansion? Because copper is a solid, so the molecules are very tightly bonded together, so they separate a little. Water is a liquid, so the molecules are less tightly bonded, so there are still small separations. Now, nitrogen is a gas, so the molecules are free, they're not bonded, so they can separate the most. So that's why nitrogen is the one with the greater expansion. Now, figure 5.1 shows a thermometer with a range of -10 Celsius to 50 Celsius. Explain what is meant by the sensitivity of the thermometer. It is basically the size of movement or change in the length per degree. So how much effect will the change be obvious on the thermometer? The linearity of a thermometer is basically the change in length of the liquid column is the same for all degrees. So all of the spaces between the degrees will be the same. Now, going to the second, this is another question from another past paper. This is from 2014. In the box below, sketch a diagram to represent the molecular structure of a liquid. Show the molecules as small circles of equal size. Of course, you have to make them equal size. Now here, the most important thing in drawing this is that the molecules have to be randomly positioned. You have to put them in a random way, and most of them will be touching each other because they are not really, there aren't so much spaces between them. Now, a teacher in a school laboratory pours liquid ethanol from a bottle into a glass dish. Of course, maybe you're familiar with ethanol from chemistry. The glass dish rests on an electronic balance. Although the temperature of the laboratory is below the boiling point of ethanol, the mass of the ethanol in the dish quickly decreases as ethanol evaporates. So even though that the temperature is below the boiling point, the ethanol still evaporates. State the effect of this evaporation on the temperature of the remaining ethanol. Now, what happens to the temperature? It decreases. Why does it decreases in terms of the molecules? Now, because the most energetic, the faster molecules, they escape from the surface. So the only ones are left are the ones with the less energy. So less energy, which means less temperature. Now, the specific latent heat of vaporization of ethanol is 850 joules per gram. Calculate the thermal energy required to evaporate 3.4 grams of ethanol. Now here, the rule is simple. The energy equals the mass times the latent heat of vaporization. Now it is 3.4 times 850. Now here I wanted to first convert it, but then I changed my mind because this is in grams and this is in grams. So you don't need to convert the mass because the latent heat of vaporization is already given in grams. So we just multiply them. It will be 2,890 which will be, you will see it written as 2,900 joules. Now, suggest 2 ways in which the rate of evaporation of ethanol from the dish can be reduced. So we want the ethanol not to evaporate as much. So we can either reduce the temperature more, or reduce the let's say the drought of the dish, and we can increase the humidity of the air in order to decrease the evaporation of ethanol. Okay. Now this is from a specimen paper for an examination in 2020. So a solar panel is mounted on the roof of a house. Figure 4.1 shows a section through a part of the solar panel. So this is one part of the solar panel. A pump makes water flow through the copper pipes. These pipes are taking from like a sideway view. The water is heated by passing through the solar panel. Select and explain 3 features of the solar panel that maximizes the final temperature of the water. So we want the temperature of the water to be increased. Now, since we have 3 features, why do we have 4 marks? So the listing is 1 mark and the explanation part is 3 marks. So first of all, let's go to the listing. First, we have the copper pipes, right? Then we have the metal backing sheet, which is painted black. And of course, we have the insulating material. And we have something that I didn't write here, which is the trapped air, which is a poor conductor of heat. Now, the copper, which are the pipes are made of, from, is metal, which is a good conductor, which will conduct the heat through the pipes, which will heat up the water. Now, the metal backing sheet, which is painted in black, as well as even the copper pipes, which are also painted in black. Black is a good absorber, so it will increase the heat absorbed from this sunlight, which will increase or maximize the temperature of the final temperature of the water. It will make it hotter. Now, finally, the insulating material, it will reduce the heat lost from the sheet or the pipes. And of course, the trapped air is a poor conductor of heat, so it will keep the heat energy here trapped, so it will not lose any, we will not lose any heat. Okay, now let's go to the next one. No, sorry, 4. Yeah, so here we have, just a second. Yeah. Now here we have explain in terms of molecules why it is possible to compress a gas but not a liquid. Why can we compress a gas but we can't compress a liquid? It's simply because the gas molecules are very far from each other. They're very far apart, while the molecules of the liquid, they are very close together. They are compact, so you can't basically compact them more, but you can compress a gas. Now here we have 2 containers which are made of insulating material. They have the same volume of water at a room temperature. The containers don't have any lids. The volume of liquid in each container gradually decreases. Now, after a certain time, the temperature of the water has decreased to below room temperature. Now, why did the temperature decrease in terms of molecules? Because as we said before, the faster or more energetic water molecules evaporate while the slower or less energetic molecules, they remain, which will make the temperature decrease. One of the container is wide and shallow, while the other is narrow and deep. Predict which container has the greater rate of cooling. It will be the wide container because it has a larger surface area, which will make the rate of evaporation faster. So there's a great chance of evaporating, because when you make the surface area bigger, you're allowing more molecules on the surface to escape. So that's why it will be the wider container. Okay. Now let's go to the next one. A student carries out an experiment to find the relationship between the pressure P and the volume V of a fixed mass of gas. So here the mass is constant. The table contains 4 of her sets of measurements. Now use the data in the table to suggest the relationship between the pressure and the volume in this experiment. So what is the relationship between the pressure and the volume? If we multiply the pressure multiplied by the volume, it will always give us a constant value, which is 7,500, or about this number. So as you can see, if you double the pressure, the volume will be halved. So you can either put it this way, or you can say that when you multiply them, it gives you a constant value. Now state the property of the gas apart from the mass, because we said that the mass is fixed. What is the other property that has to remain constant while we're studying pressure and volume? And that is temperature. So you can't change the temperature and then study the pressure and the volume. You can't change all of these 3 variables at the same time. We said that we keep one of them as a constant and study the 2 other quantities. A lake is 5 meters deep. The density of the water is 1,000 kilograms per meter cube. Calculate the pressure at the bottom of the lake due to this depth of water. So this is actually a question that we've taken in the previous chapter, which is rho GH. Rho, which is the density, which is 1,000, G, which is the gravitational acceleration, and H, which is 5, which is the depth. So we'll end up with 50 kilopascals. Now, a bubble of gas escapes from the mud at the bottom of the lake and rises to the surface. Now, please place 1 tick in each row of the table to indicate what happens to the volume, the mass, the density of the gas in the bubble. Assume no gas or water vapor enters or leaves the bubble. So basically what will happen, since it's rising, the density will decrease. Now the mass will not change and the volume will increase. Since the density is decreasing, so the volume will increase. The volume of the gas in the bubble is increasing, which makes the density decrease and makes this bubble of gas rising through the lake. Okay. Okay. Now let's go to this one. State 2 ways in which the molecular structure of a liquid is different from the molecular structure of a solid. Basically, the liquid molecules, they can move past each other, or we can, in terms of solid molecules, we can say that they have a fixed position, while the liquid molecules, they have a random arrangement, or we can say that they have the solid molecules, they are arranged regularly. Now, explain in terms of energy the process which takes place as a solid as its melting point changes into a liquid at the same temperature. So at the same temperature, we're just changing the phase from a solid into a liquid. Now, what is meant by, what is the process that happens in this phase change in terms of energy? That we need thermal energy is needed to break the bonds between the molecules, or to overcome the attractive forces between the molecules. So that way we are increasing the potential energy of the molecules by giving them this thermal energy. Now, during a severe snowstorm, a layer of snow, ice crystals, forms on the body of an animal in a field. The snow and the surrounding air are at 0 temperature, so it's the same temperature. The snow begins to melt. The mass of the snow that falls on the animal is 1.65 kilograms. The specific latent heat of fusion is 330,000 joules per kilogram. So we want the thermal energy. We just multiply the mass, which is in kilograms, multiplied by the latent heat, the specific latent heat of fusion, and we just multiply them by each other. Now, the animal derives energy from its food to maintain its body temperature. What is the energy change? It changes from the food, which is chemical energy in the body, into a thermal or internal energy. Okay. So this is not in the, this is chemical energy in the body, which is mainly from the food. Okay, let's go to this one. This is actually interesting. Figure 4.1 is a design for a remotely operating an electrical switch using air pressure. Now, the metal box and the pipe contain air at normal atmospheric pressure, and the switch is off. Now, when the pressure in the metal box here, and the pipe is raised to 1.5 times the atmospheric pressure, so 1.5 times. How can you do this? By pressing this rubber box cover, so the switch comes on. So if you press this, it comes on. If you don't, it turns off. Now, explain in terms of the pressure and the volume how the switch is made to come on. Now, when you push the flexible rubber cover, the volume here will reduce, right? So when the volume is reduced, the pressure goes up. So the pressure of the metal box and the connecting pipe, the pressure of the air inside them will be increased because the pressure goes up. Now, normal atmospheric pressure is 1 times 10 to the power 5 pascals. At this pressure, the volume of the box and the pipe is 60 centimeter cube. Now, we want the reduction in volume that must occur for the switch to be on. We don't want the second volume. We want the change, the reduction. So in order to get that, we have to subtract. But I don't have the second volume, so I have to get it first. So here first, we get the second volume, the volume after pressing the button. And then we find the reduction by subtraction. So V1 P1 equals V2 P2. V1, which is the first pressure, which is this, times P1. This is the P1, the pressure, and this is the volume. The initial volume equals the second volume, as we said in the question, is 1.5 times the original. So it's 1.5 times 1 times 10 to the power of 5. Times V2, which I want to find. So eventually V2 is 40 centimeters. So how much is the change between 60 and 40? Because this is what we're looking for, the reduction, which is 20 centimeters cubed. Now, explain in terms of air particles why the switch may operate without the rubber cover being squashed when there is a large rise in temperature. Now, surrounding this pipe, you have air particles, right? Now, if you raise the temperature at high temperature, these molecules, the average speed of these molecules will be greater. So you will have more collisions between the air particles and the connecting pipes, which will create more pressure and possibly could turn the switch on even without pressing this button. Okay. Now, let's go to this one, the specific heat capacity of a substance. Now, we said that this is the thermal energy needed to heat 1 kilogram of matter by 1 Celsius. Now, figure 4.1 shows a cylinder of aluminum heated by an electrical heater. So this is the electrical heater. Here we have the voltage and the thermometer and, of course, the aluminum cylinder. Now, the mass is 800 grams. The energy delivered by the heater is 8,700. and the temperature, it increased by 12. So this is the temperature change. We don't have an initial temperature and a final, we only have the change. So as we said, according to the conservation of energy principle, the energy supplied by the heater is equal to the energy gained by the aluminum cylinder. So the energy supplied by the heater is 8,700 joules equals the mass times the specific heat capacity times the temperature change. And of course, we change the mass into kilogram by dividing it by 1,000. So the specific heat capacity will be 906.25 joules per kilograms Celsius. Now, calculate the thermal capacity. We said that the rule for thermal capacity is the mass multiplied by the specific heat capacity. So we multiplied the mass also in kilograms, multiplied by the specific heat capacity. And so we get 725 joules per Celsius. Okay? Yeah, so, yeah, now let's go to this. Yeah, we've taken this before. Yeah, so this is for the solar panel. This is the other part of the solar panel. We said that this is a solar panel system. Now, here it says that during one day, 250 kilograms of water is pumped through the solar panel. The temperature of this water rises from 16 to 38. So the change is 22. Now, the water only absorbs 25% of the energy. So it doesn't absorb all of the energy. It just absorbs 25%. Now, the specific heat capacity of the water is 4,200 joules per kilogram Celsius. Now, we want the total energy which was incident on the solar panel that day. Now, what I do is I do it as an inverse operation. So since the water only absorbs 25%, so I can find only the energy of the water, the gained by the water, and then multiply it by 4 to get the whole 100%. So first of all, we get the energy absorbed by the water, which is m, the mass, which is 250, multiplied by 4,200, which is the specific heat capacity, multiplied by 38 minus 16, which is the temperature change. Now, this is the energy absorbed by the water. Now, we said that the energy absorbed by the water is 25% of the total energy. Now, 25% can be written as 1 over 4. Now, the energy absorbed by the water is 2.31 times 10 to the power 7. So we multiply both sides by 4 to get the final answer. So the total energy, it is the energy absorbed by the water multiplied by 4, because the energy absorbed by the water, it's only the quarter. So we want the whole energy. We multiply it by 4. Now, the solar panel in figure 4.1 is designed to heat water. A person is deciding whether to install solar panels on her house. List and explain 3 pieces of information she needs to consider in order to make her decision. What information that you have to consider to decide whether you will install solar panels or not? First of all, you have to decide whether the roof is shaded, so that if it's shaded, less sunlight will reach the panels and the water will not be heated enough. And you have to consider your household needs. How much water do you need in order to know how much number of panels and the amount of water that you will need. And of course, you have to take into consideration the cost of the installation of the panel. Now, as for the final question, which is the sun releases energy as a result of nuclear fusion. What is the meaning of nuclear fusion? It's basically when nuclei join together, so to produce helium and energy, and it happens in the sun.